look at linear equations to start. So for linear equations, we're actually just going to look at one at a time. So you have, this is considered like a parent function. And this is, sorry, I should say the general function of a linear equation. And the reason they call it general is because they use variables to represent parts of the line, okay? So when they represent a linear equation to you, it's just a straight line somewhere on a graph. It could look like this, it could look like this. There's actually an infinite number. There's a whole bunch of them, and they technically go on forever. There's two major key points to a linear equation that really help you in understanding where it ends up on a graph, and they also help you with manipulating the equation. I'm just going to quickly put in, we have a y and an x-axis. One of the points is called the Y-intercept, okay? So that's where the line crosses the y-axis, okay? And algebraically, so that's when we look at y equals mx plus b. Algebraically, this is known as the b value, okay? But I'll put in brackets, this is the Y-intercept. That Y-intercept is really important for this version of a linear equation, okay? Because b happens to be like an exact value. If it's 3, well, then I know I can plug 3 in here algebraically. If it's -2, I know I can plug in -2 algebraically. So it helps me build my equation really quickly in this version, okay? There's actually different versions of linear equations. I don't know if they've shown you too many of them. This one's called slope y-intercept. There's also point form, point slope form. We'll just focus on this one right now, okay? The other thing that's important is what the M is considered the slope. And the slope is, they'll usually refer to it as the rise. So let's say I'm from here. They'll talk about how much it goes up. This is the rise. And how much it goes left and right. This is the run. So what they'll say is slope is equal to, yeah, rise over run.
Can I sit with you?
In a minute, okay? Rise over run is equal to rise over run, which is also equal to m. And a way you can find slope is there'll be a little equation that's like this. y2 minus y1 divided by x2 minus x1. You can sit with me. So this little piece here is really important in finding the rest of the expression. It's the number that goes in for the letter m. What you'll need to have is you need to have at least 2 points. If you have 2 points on any graph, so I'll kind of draw a graph out again. If you have 2 points on any graph, you can always connect them with a line. Okay, so if I have a point there and a point there, I can connect these with a line. If I have another point here and another one here, I can also connect those with a line. So all you need is 2 points to be able to draw a line, and as long as you have those 2 points, you can actually make the equation. Whoops, that's not what I wanted. Okay, so what I'm going to do is I'm going to put some arbitrary points here, and we're just going to try to build an equation from it, okay? So I'm going to draw a Cartesian plane here. So I don't know the answers to this one, so it might come out a little tricky. But I'm going to put a point here, and we'll say that's at roughly 1, 2, 3, and 1, 2, 3. Oh my gosh, I got to count this. 1, 2, 3, 4.5. Nah, let's just say 4. So this is at 3, and 4 is one of the coordinates. And I'm going to make another coordinate down here. Actually, I'll make it the x-intercept. 1, 2, 4, 5. So this is -5 and 0, okay? I've just chosen 2 arbitrary points. But what I wanted to tell you is that I can make a line out of this, okay? I'm not always the best at connecting this all the way through, but oh, not bad. There we go. We've got our line. If I have those 2 points, in order to write my equation in slope y-intercept form, so y equals mx plus b, I need to find the y-intercept. So I got to figure out what this is, okay, which is the b value. And I also got to figure out the rise over the run, okay? There's a couple ways we can do this. A y-intercept is unique. A y-intercept, so we'll put y here, happens to be when the x value This is when the x value is equal to 0. So because I have my general equation here, y equals mx plus b, okay? If I already have the slope, I can figure out my y-intercept by just plugging in x. At the moment, we don't have a slope. So I'm going to have to work on that to start. So there's that little equation I showed you above, y2 minus y1. Those are in reference to these coordinates. I can call any coordinate 0.1 and any one 0.2. I just have to be consistent. So I'll call this number 1, and we'll call this number 2. So when I go to label it, this will be x1, this will be y1, this will be x2, and this will be y2. So now I can use my little slope, which is equal to m, which is the rise over the run, but I'm just going to write the equation for the last part. So y2 minus y1 divided by x2 minus x1, okay? So I just got to plug or substitute. My y2 value is 0, so I get 0. My y1 value is 4, so I have to subtract 4, and then we have to divide that. My x2 value is negative 5, and my x1 value is the number 3. So when I work that out, I get negative 4 over negative 8. Now if I do a negative divided by a negative, it's actually a positive, and I can reduce this fraction to 1 over 2. That's a pretty nice one I made. So what that means is the slope, or we also represent it with the variable m, is equal to a half. So I'm going to write that general equation a little lower again. We have y is equal to 1/2, or 1 over 2, x plus b. Okay, so I got part of the equation. We got the slope part. The other part we need is the y-intercept, okay? So remember I said that's when x is equal to 0. Now that I have the slope, I can very quickly find a y-intercept. I'm going to replace x with the number 0 and just figure out what y is equal to, and that would give me a y-intercept. So because I've built half this equation, it will help me solve the other part. The reason is if we look at this graph, A, I didn't really draw it correctly, and B, it's really hard to tell what that number is. It could be a decimal value. I'm not 100% sure. So graphically, it's a hard thing to find, but algebraically, which was with the letters and the numbers, we can get a good algorithm to solve it. So we have y is equal to 1 over 2. The x value will be 0 plus b. And then I just have to simplify. 1/2 times 0 is just going to be 0. Okay. Y equals mx plus b. What am I missing here? Oh, I'm sorry. Why did I put that? Sorry, guys. I had a little brain lapse there at a moment. In order to do that, we'd have to have the other coordinate. That's actually the only point I don't have the other coordinate. What I would do instead is I can take any of these 2 points that we had before, and we're going to plug them in for x and y, and b will be what we isolate for. So I apologize. 0 is the only value that I couldn't have used. What we'll use instead is the coordinates here. So this is an x value, so I'll replace x with it. I'll put this in as an x. X is negative 5. And we're also going to replace the y value. The y value happens to be 0 here. This is an x-intercept. So y is equal to 0. Okay? When I go to work this out, I'm going to get 0 is equal to negative 5 times a half. So if you remember your fractions, that's the numerator times the numerator and the denominator times the denominator, which gives you negative 5 over 2 plus b. And if we want to get b by itself, we just have to move this to the other side of the equation. So because it's negative on this side, when we balance equations, we just use the opposite operation. So on the left side, we'll do 5 over 2 plus 0. And on this side, we're technically doing the same thing. We're going to add 5 over 2. A lot of times they'll just say you flips the operation, which is fine. You can do that. But what's happening here is we're actually creating a 0. This is canceling out sometimes. On the left side, 0 plus 5 over 2 is pretty simple. It's just 5 over 2. I could write that as a decimal number, like 2.5 if you want. I just kept it as a fraction. We could also say this is equal to 2.5. But when we go back to our graph, what that means is, and this is why it was visually difficult to do, this means this was at 0 and 2.5, or 0 and 5 over 2, however you want to represent it, okay? The last thing we'd have to do is put that equation all together. Y equals mx plus b. So our m value we'd already solved. It was a half. So I'm going to replace m with 1/2. The x stays in here. And the b value is what we just found at 2.5. So I can say plus 2.5, or I can say plus 5 over 2. It just depends on what your teacher really prefers if they want fractions. See, the odd way of writing this one is just because I have a fraction at one point and a decimal. We usually try to keep the same symbol. So if we're using like fractions to represent things instead of decimals, we'd use that.